Welcome to APIs You Won't Hate. My name is Mike Bifulco. I'm flying solo for today's episode. Phil and Matt are both indisposed this month. We've had a complicated month of scheduling and trying to get a hold of each other. Actually recording this on Matt's birthday, so happy birthday, Matt. Hope you're having a good one. Phil is, as I understand it, either riding through or recovering from a ride through Italy after his tree planting season was completed. And so for this month's episode, I'm speaking with a friend and former colleague of mine, Sean Falconer, who's the head of developer relations at a company called Skyflow. We'll chat a little bit about designing APIs for privacy, what it's like to take privacy into consideration, and the things that he's learned about designing APIs with privacy in mind, as well as the strategies that Skyflow has taken to designing APIs and systems that work with other APIs. We will probably have a few of these interview style episodes, and I would love to hear your feedback on these as you listen to them. If there are follow-up questions you have for the folks I chat with, feel free to send me a direct message on Twitter at Irreverent Mike. If there's someone that you think might be interesting for us to talk to interview about their team working on APIs, their history, those sorts of things, would love to chat with them. You can always get in touch with us at the APIs You Won't Hate Twitter handle. Again, you can chase me down, and there's a contact form on our website at apisyouwon'thate.com. Right. So I'll be back in a few moments to speak with Sean Falconer from Skyflow. Before we do that, let's hear from our sponsors. Thanks. This episode of APIs You Won't Hate is brought to you by Treble. Treble is an API management platform that helps developers and companies understand their APIs better, and in the process saves a lot of time and money. What started out as a solution for their own problems has grown into a platform that's processing more than 9 million API requests a month. Treble features real-time API monitoring, automatically generated documentation, logging and error tracking, API analytics, and one-click API testing. To learn more about Treble, go to treble.com/APIsYouLove. That's Treble, TREBLLE.com/APIsYouLove. Thank you so much to Treble for sponsoring APIs You Won't Hate. This episode of APIs You Won't Hate is brought to you by Lob. Lob is a group of passionate people working towards their vision of increasing connectivity between the offline and online worlds. They help developers send postcards, letters, and checks as easily as email through RESTful APIs. Lob is looking for engineers at all levels interested in joining a successful growth stage startup. They offer collaborative culture, supporting teamwork and mentorship. Their founders have a strong vision of building a product-led organization, and it's an opportunity to have a big impact on Lob's business and engineering culture. Lob is built using open API specifications for contract testing, generating documentation, and soon SDKs. Their API is written in a mix of JavaScript, Golang, and Elixir, and their customer-facing dashboards are built with Vue.js. If you're interested in joining Lob, check them out online at lob.com/careers. Thank you so much to Lob for sponsoring APIs You Won't Hate. All right, and I'm here with Sean Falconer from Skyflow. Sean, how are you doing today?
I'm doing great. Thanks for having me.
Yeah, of course. So, Sean, you and I met through, I don't know, some strange serendipity probably 2 years ago or so at this point. In past lives, both worked at Google. Weirdly, we both worked on the same DevRel team at Google at different times. If I understand right? Did you work on the assistant team for a bit?
Yeah, technically, I was on the assistant team when I first joined Google, although I was kind of like the one outlier working on a product that no one else in the assistant team worked on. So eventually, I was reorged into another part of Google.
Gotcha. Yeah. Okay. And then I guess through mutual friends, we sort of met each other by way of some social hangouts at Google and kind of talked while we were both there. I think you left a couple months before I did and started your role at Skyflow. I left, boy, I guess last month. Is that right? That can't be right. Yeah. I guess I left early March of this year. So last month, technically. And when did you join Skyflow?
I joined Skyflow as the head of developer relations on January 3rd, so at the very beginning of the year. And then before that, I had spent a number of years, like you're saying, at Google working on a number of different API based products in sort of the communication and chatbot space.
Yeah, right on. So tell me a little bit about that. You can give me some history of yourself and Skyflow if you like.
Yeah, sure. So in terms of my history, before Google, I was a startup and I did that for about 7 years. And then before that, I spent about a decade in university doing 3 degrees in computer science and a postdoc in bioinformatics. So my experience is kind of like all over the place. My undergrad, I was focused on like theory and computation, so very like math heavy. My master's degree was in like AI and machine learning. And then my PhD I did in a human computer interaction software engineering lab. So kind of a little bit more closer to like social sciences. And then I ended up at Stanford doing a postdoc in the medical department in bioinformatics, having never taken having never taken a biology class in my entire life. And then I was kind of on this path of wanting to be an academic or a professional researcher. And then when I was there, I realized it wasn't really a great fit. I was pretty good at it, but I wasn't, waking up Saturday morning, super excited to necessarily do the research that I was doing. And I ended up starting a company while I was at Stanford. So after a year, I left to do that company full time.
Yeah, wow. So you've taken about as non-standard of a path as is humanly possible.
That's my goal.
Yeah, I can't think of many more curveballs you could throw in there apart from, I
Mm.
don't know, maybe military service or being imprisoned or something like that for a little bit. So, do you want to talk a little bit about your startup and kind of what was going on there?
Sure. So this company I started with two other Stanford students. I was the technical co-founder. One was from the MBA program at Stanford, and the other was from the design school. So it was kind of like felt like this perfect combination of expertise coming together. And we were really interested in trying to build bring technology tools to kind of underserved market for jobs. So there's lots of technology tools that are built for people like you and me that have university degrees that have desk jobs, white collar jobs, especially in the tech industry. There's not a lot of technology that's built on both the hiring and also the finding job side of the blue collar jobs or for restaurant jobs, hospitality, hourly work. So originally we had raised money around creating this like temporary staffing company for blue collar workers that was kind of like this decentralized model where we would use technology to place different workers. And that was what we originally raised money on. After a little while, we realized that we couldn't really scale that business. We were great at the technology, kind of sucked at being a staffing company, and started to pivot into more permanent jobs. But within the first 10 months or so of running that company, we kind of did all the things that you're not supposed to do as a founder and got to a place where we essentially had to lay everybody off in the company. One of my co-founders left a couple weeks after that because just like the stress of having to go through that. We lost a key hire. We went and rehired one of the engineers that we had laid off that was like sleeping on my couch at the time because he had nowhere else to stay. And then essentially myself, one of my co-founders and that engineer like rebooted the company, started from scratch and started doing things right. And then we eventually were able to grow that business, raise a number of other rounds, and got to a place where it was cash flow positive. And after doing that for 7 years, it was never going to be the rocket ship that we had hoped it would be, but we got it to a pretty good place and I was kind of ready for something new. So I stepped away after 7 years to focus on other things and stayed on as a consulting capacity. And that's how I ended up moving into developer relations and ending up at Google.
Yeah, wow. 7 years is a very, very long time to hang on for that kind of a ride. I'm sure that taught you a lot of life lessons and kind of brought you through the gamut of social experiences and emotional experiences and things like that. That sounds pretty heroic, man.
Yeah, I basically spent 7 years at an early of like the earliest stage of startup that you can be, crawling through the mud to try to make things happen. But there's a
Yeah.
lot of I learned a ton along the way, and it beyond just engineering, and I think that's what ended up they really attracting me to roles in developer relations because it's a much more cross-functional engineering type of role than traditional engineering. And through running a company, I had to learn a lot of things just because there's nobody else there to learn those things like marketing and sales and business and how to take a product to market and create a brand awareness for it and things like that. And those are all essential skills of and complementary to developer relations.
Yeah, absolutely. I've been doing the developer relations thing for a few years at this point, and it is eerie how parallel it is to running a company. You switch hats fairly regularly and have to have a voice for all of the people that you represent, both within the company and outside of the company. Okay, so let's say we fast forward a little bit to the beginning of 2022, and now you're the head of DevRel for Skyflow. Can you tell us a little bit about Skyflow and a little bit about the mission there and what DevRel is hoping to accomplish?
Yeah, sure. So Skyflow, in a lot of ways, is based on a pretty simple idea. Like, you, me, essentially every consumer for the past 20 years has been giving up like our personal information to companies to buy products, create accounts, get medical help, fulfill prescriptions, and so on. We have all these like thousands of accounts like this, and we kind of blindly trust that those businesses are protecting our data. However, if you do, a quick Google News search for data breach, you'll quickly learn that most of those companies aren't necessarily doing a great job securing our data. There's actually around $56 billion lost to fraud and identity theft every year. So as someone in the technology field, I think it's like natural to ask, like, why is this so hard for these companies to protect customer data? And it really comes down to kind of a simple answer, which is it's not their job to do that. Their job is to create a ride sharing app or serve videos online or, deliver groceries in an instant or something else. And it's similar idea to like if all the money that you earned, you decided to store that in your house, you probably couldn't do a great job of protecting it. So you essentially stick it in a bank because a bank has the resources, the expertise to hopefully protect that. And also, they become the target of attackers rather than you being the target of those attackers. And in many ways, Skyflow is based around this principle. It's like a bank, but for your PII. So we're a zero trust data privacy vault delivered as an API. And we essentially believe that privacy and security can be as simple as payments have become in Stripe or, sending an SMS into Twilio.
Yeah. Okay. So that's really interesting. So you're shouldering the burden of carrying PII privacy related data for the people that are using your APIs. Can you tell me a little bit more about that? We'll start with the 100 level definition of what a data privacy vault is.
Yeah, so the data privacy vault essentially isolates, secures, stores, and tightly controls access to manage and use sensitive data. And it's based around, in part, around this principle of isolation, which is a well-known concept in encryption. Like, you don't store encryption keys with your data, or something like API keys. You don't want to store API keys with your application, or store your database access codes with your commit that to GitHub. You put that somewhere else. You put that in key management system outside of your application. And the idea of a data privacy vault is also this is based around this principle of isolation, where you're going to essentially descope your application database in your application infrastructure from having to store that data and secure it. And with that, there's a lot of features of a data privacy vault where you need built-in privacy preserving technologies like encryption and tokenization, data masking. You need isolation of the network, zero trust model, data governance and ACL management, so that you can really give like fine grained control over what actually has access to the data, and support a number of different use cases for structured and unstructured data, solve all kinds of different privacy issues like log files, PII usage, data pipelines, and then ultimately you are doing all of this like security and privacy. But the reason people store customer data is so that they can actually use it. So you need to also be able to support things like privacy preserving analytics, secure cloud functions to pass data securely to third parties, and provide APIs into that data in a way that people can actually consume it and incorporate it into existing infrastructure. And really, the inspiration for this, for like Skyflow, came from companies like Netflix and Apple and others that pioneered this idea of a data privacy vault. So they recognized this, they had this key insight that I think is something that everyone should start to grasp, but hasn't quite got there, which is that customer data is something special. It's different than regular application data. So they took their customer data and they essentially descoped their systems by moving it into their version of a data privacy vault. And that became the single source of truth of all that customer data. And that way, when they build applications, they don't need to necessarily worry about what happens if someone gets into the database. Because if they get into the database, the only thing they're going to see is essentially tokenized versions of that data. They're not going to have the actual plain text value. So they're really de-risking their systems, and then also prevents all these other things from happening, like accidentally logging PII. Because if it's not, if your systems don't have access to the plain text values, then you're not going to accidentally log it.
Sure. Yeah. So let me take a step back. So I'm trying to imagine sort of what this looks like from the end user version. So if I'm a technical lead at some company building something that obviously stores PII that we want to secure in the data privacy vault, is the idea essentially that you take let's say the user table, right, where I have my usernames and email addresses and maybe mailing addresses and things like that. You take that information and push it into the data privacy vault and replace it with some sort of token that I can go and ask for that the specific data that I want later on. Is that essentially the idea there?
Yeah. So in the very like simplified view of that is exactly that. So I actually am speaking. I have a talk that I'm giving at MongoDB World in June that is titled "Your Users Table Doesn't Belong in Your Database," which is essentially that idea. Is like, we need to stop storing PII in our user and customer tables within our applications and move it into a data privacy vault, and then just store references to it. Just like most people, when you're doing credit cards, the reason people do use companies like Stripe, which you're very familiar with at this point, is Stripe is de-scoping their customer systems from having to store credit card data, and you get like PCI compliance out of the box. And what Stripe gives you is a token that is a reference to the credit card information. So that same concept can essentially be applied to all sensitive customer data.
Sure. Okay. Yeah, that makes sense. So And then that makes it essentially agnostic of what is underlying the system on the application side, right? You don't care if I'm accessing my data by way of GraphQL or MySQL or whatever. And so your APIs then must be fairly flexible in terms of interop with various libraries. So do you have like client libraries built out in specific languages, or is it the sort of thing where it's an API spec that is meant to be malleable depending on how you're accessing it?
Yeah, so there's both. We have, we're an API first company. So everything that, even though we have like tooling, like we have a product called Skyflow Studio that allows you to do a lot of the management and creation tasks that you would do for like creating a vault and governing access. You can also do all those things from an API as well. The studio is essentially just like a visual representation of those APIs. And then in terms of like SDKs, we provide client side SDKs in iOS, Android, and web for the collection component. So if you're collecting PII, PCI, or PHI, then you want to do that in a secure way, either through an iframe that's hosted by us with our secure elements, and then that data passes directly to Skyflow into your vault, or doing some sort of custom form that essentially so that the data never ever touches your backend. The goal, the sort of ideal scenario is always that you're essentially tokenizing data as early as possible in the life cycle of that data, and then detokenizing it as late as possible. So we've built a lot of our APIs and our infrastructure based around this principle, where at collection, the ideal scenario is that that data is going directly to Skyflow in the vault, into your vault, and then you're storing tokens. And then if you need to move that data to a third party, say you need to call Stripe's API to do a credit card transaction, or you need to call Twilio to send a text message, well, then you're not calling Twilio or Stripe directly. You're calling Skyflow's connections API, passing that token, and then we automatically detokenize it in a secure way, proxy it to the third party, and then pass the data back to you. So that
Got it.
way, you're really removing the risk of your system ever being exposed to this data. And then on top of that, there's other usage scenarios. So an application storing PII, let's say social security number, they might need to show the last four digits of the social security number at some point. So it's not necessarily, you don't want to show the token of the social security number to your customer support agent that needs to validate the person's account. The customer support agent, the use case there is that they need to maybe see the last four digits. So we also support APIs and also configuration that allows you to support these different types of use cases. We're dealing with such a specialized type of data where it's the number of sort of sensitive fields that you store about a customer in like normal scenarios. It's kind of known. There's only probably a few hundred of different types of PII, PCI, and PHI that you're going to store. So a lot of the sort of semantics around that type of data dictate the types of use cases that you're going to do with that data. So that allows us to do some really cool things, like provide a lot of best practices and support for use cases out of the box.
Yeah. So in other words, it's pretty well known that if you're storing a social security number, it's very likely you're going to want to extract just the last four sometimes to validate something, and maybe even a phone number as well. I've seen that for two-factor auth things. I guess
Exactly.
that so that must
Um,
apply essentially to all the various types of data, right? Like PHI is personal health information. Is that right?
yes. Yeah.
Got it. So I
Yeah.
could imagine there being lots of health related things where it's like, I don't know, maybe you can tell how little I work in health, but maybe you only want to expose my blood type when I choose that that's worth doing or something like that. Yeah.
Yeah, I mean, when
I-
you think about like clinical trials, for example, that our companies will run, there's different types of people that need access to the data from clinical trials, and there's different use cases that determine like how they want to see that information. Like the government might want to be able to know certain information, but not know who the individual is. But maybe I don't know, like a doctor or something like that needs a different level of access. Like so, essentially, you want to be able to through Skyflow's data privacy vault and the APIs that we support, you can essentially create different roles and policies around how the specific what's the specific business case for access to that data and how they access it. So you can get really fine grained control over, okay, well, these people need access to these specific columns, and maybe they need them in plain text. They might need some mask values, and then everything else can essentially be redacted. So it's really based around the principles of least privilege, where you want to have like a zero trust model and you're giving explicit access to the data based on the business requirements of the service that needs access. But
right.
that
Got
key
it.
insight, like that you kind of alluded to around the fact that a credit card number social security number. Like we call these numbers, but they're really data structures. A credit card number is not, you would never multiply two credit card numbers together, for example. So they're not really like a number. They're more of a data structure. And the data structure and the semantics of use dictate how people actually use it. So they just usually with a credit card number, there's only a couple different use cases that you're going to have for storing a credit card number. You're going to need the last four for validation. And then you're going to use the entire credit card number perhaps to be able to carry out a transaction through like a third party merchant. And then everything else essentially just is redacted, or maybe it's tokenized because you need to validate that a record exists. And that's really it. So because of that sort of insight around the fact that each of these the types of PII, PCI, and PHI are really data structures that dictate the types of use cases, we've been able to develop a proprietary technology called polymorphic encryption, which allows you to actually perform operations over encrypted data. So when you think about like privacy and security, you always want to be storing data at encryption and at rest, but to actually use the data, you need to decrypt it. And at that point, you could potentially log it by accident, or maybe on purpose, or someone could do a memory dump and get access to the plain text values. But with polymorphic encryption, you can actually do encrypted operations. So even if someone did a memory dump, all they'd see is encrypted strings. And the key insight there was around the idea that each of these PII type of data, like a social security number, is this data structures can be broken up into these different components. So we're able to apply different types of encryption methods to each of those components and essentially pre-compute the sort of indices and the types of based around those use cases. So you can perform essentially production grade operations over encrypted data very, very
Yeah.
fast.
Wow. Yeah. So that's removing quite a few vectors for trouble along the way, right? Like you said, printing things to logs, or accidentally throwing something in a debugger loop or something like that. That's really
Mhm.
interesting. I think we zoomed by it for a second there, but to me, the notion that all of these bits of information are their own data structures and not just special types of primitives, like the credit card not being a number thing. I think you probably made a lot of people just freeze in their tracks with that. That's one of those things that, like, it's a bit of a revelation unto itself, and definitely reframes the way that you think about things when you kind of realize that. I think that's a really interesting point to get across. And definitely, I'm sure there's a lot of like API devs who are kind of listening to the conversation and wondering the last time they set up a database framework or did a migration, like, were you really thinking about a credit card as just a number? Does that even make sense to do? And how do you validate that and make sure you're working correctly from there? So,
Yeah, there's
uh,
a lot of things that you're able to do once you sort of have that insight, because some of the things that because we had this insight, we were able to develop the technology of polymorphic encryption, which I mentioned, but we're also able to create a lot of things that make it just easier, developers to kind of define the schemas of their vault, because we've handcrafted what essentially over 50 different, we call them privacy preserving data types, where you're not just creating a string column for a credit card, you're creating a credit card column. And because we understand that that's a credit card at the level of the vault, then we can pre-configure a lot of the privacy and security controls around it, like having a masking regex that automatically masks the first 12 digits and only shows the last four, or using things like format preserving tokenization, so that a tokenized version of, say, an email still looks like an email but has no exploitable value.
sure. Yeah, that's to me falls under the I guess characterization of something that, like, I've always thought of data security and privacy as something that I'm thankful there's smarter people than me working on, and to be able to have sort of utility level understanding of those things really makes it like accessible to people who don't consider themselves to be experts. Along those lines, I guess I'm curious, for if you're talking to someone who's building an app or service or whatever the case may be, and they asked you how they can do a better job of paying attention to data security and the sort of world that you live in, uh, where are places you go for information about that, to learn about, say, the latest and greatest in making sure things are encrypted, or making, understanding problems that other companies have had, or GDPR violations, whatever the case may be? Where do you turn to for that kind of news?
So, I mean, for me, I actually rely on a lot of like expertise at Skyflow, because there is a ton of, in order to create a product like we've created, a lot of expertise has to go into it. The You look at some of the data privacy vaults that have been created by companies internally. Shopify spent 3 years building their version of the data privacy vault with contributions from almost 100 engineers. So this isn't like something that you just wake up one day and you just like build out. It takes a tremendous amount of like effort and expertise to build something like this. And within Skyflow, our database encryption guy is the guy that Oracle's database encryption, or our director of security has 20 years experience working in the field at companies like Oracle and Salesforce, and are similar to our field CTO. So I rely a lot on their expertise to understand this space. But beyond that, there are a lot of great, I think, like conferences like IEEE Privacy and Security Conference is happening next month. I'm actually speaking there, and that is more of like an academic type of conference than a traditional like business conference. But there's tons of expertise from industry as well as from universities speaking on topics of privacy and security there. And then there's a lot of like online resources too. There's some great blogs. We'll certainly shout out the Skyflow blog. We have a lot of these experts that are writing about what are the best practices when it comes to security and privacy. And it's something that we try to educate all our customers on as well.
Yeah. So following up on that, then if let's say I was running a company and I had this revelation that I probably need to do a better job of thinking about data privacy and security, um, assuming I have something that exists already and that is released into the world, what do you think are the best sort of first steps to move in a more secure direction?
So I think so there's a couple things. So it's great that I think it's great to have that revelation. Like that's key. And the second thing is I think to try to start to understand maybe where your biggest challenges are. So with the approach that we suggest people follow is it's hard to move fast and break things, sort of Facebook mentality when it comes to APIs, because once someone adopts your API, you're kind of stuck with it unless you go through a painful deprecation cycle. And I think this is even more challenging when it comes to something like data privacy. And creating an MVP for a data privacy vault just doesn't really exist. So we spent, really the first sort of 2 years of the company like developing the product from it. And at that point, you don't have a lot of customers to sort of draw on for feedback about like, are we doing the right thing? So we had to use a lot of intuition and in-house expertise and understand what needs to be built, what's a good model to support that. A lot of our senior leadership team, and myself included, have come, big companies that have had to deal with a lot of these types of challenges. So there's a lot of understanding about the types of use cases that companies needed to solve from day one. And we've been able to, think through a lot of those challenges and problems up front, even with it before we had customers. And, some of the things that we've done to make it easy is really building around specific use cases and then being able to pre-configure as much as possible based on that use case. So a very common situation for a lot of companies, especially in like the fintech space, is they want to be PCI compliant, and they also don't want to have PCI lock-in with a specific vendor. So they don't want to necessarily exclusively work with like Stripe or Braintree or one of these types of companies. So then they want to move their credit card data essentially out of those systems and into a vault, and then be able to use any merchant that they want based on, or like multiple merchants potentially based on the deals that they're able to get on in various countries. So with that, we've pre-built a lot of the types of vault schemas that you might have for that type of scenario. Essentially, we provide a PCI vault that, with a single click, you have essentially all of the tables and columns and privacy and security controls pre-built for that particular use case. And then we also provide built-in connections to third-party platforms like Stripe, Plaid, Adyen, and many, many others. So you can really have sort of a point and click solution that incorporates a lot of these best practices based around this understanding of like, this is the problem that we're actually trying to solve, because we've seen it many, many times. Some of the other things that we did as well is, a big part of, or sort of the first stage of like a data privacy vault is really like the isolate and protect. So we need to store that data in a secure way. But then we have that data stored, but we need to be able to give people access to it. So we need to be able to govern access to it. And that comes down to defining, roles and policies and those types of controls. And what we did is we looked at a lot of existing models like, AWS or Google Cloud in terms of how they control access. And they use like a point and click UI, but that's sort of too limiting for what we're doing because we needed a lot of fine grained control and flexibility, and we don't always know exactly what level of access a particular company might need to give to an application or service. So we couldn't go with a UI based model. And then on the other side of the spectrum, we could have did something like allowed people to define policies using JavaScript or some sort of programming language, which gives you a tremendous amount of flexibility, but is a little bit like bringing a sledgehammer to put a tack in the wall. So it's just like too much power, and most people wouldn't be
Sure.
able to do it. So what we ended up doing was creating our own policy language that is kind of English-like. It's a little bit like SQL that gives you the flexibility of create or like supporting lots of different use cases while still being easy to do. And that was a big investment that a lot of design time went into. And essentially, you can write policies like allow read on name and date of birth with redaction equal to plain text, and you could even say where the person's state equals California, so that you could do like a row level constraint, or you could set just certain redaction levels to masked or to fully redacted. So it gives you this fine grained control in this really easy to use language.
So that's a real nice happy medium between the sledgehammer approach and you get what you get.
There's always this balance, right, between making something easy to use, but also following best practices around security. So to support like our roles and policies, we went with the best practice for APIs of using service account keys. So we use a service account key model, which if you're familiar with Google APIs, that's the common model that Google uses as well. But they are
Sure.
harder to use or more like less common than just a simple API key. But using an API key has a lot of downsides from like a security perspective. And so what we ended up doing was in our sort of trial environment before you're in production is we created a simple way to use the APIs to get you up and running where it's you can essentially generate like an Alice bearer token that's good for 24 hours. But in production, you can't use that system. You have to use the best practice method of using a service account key. So to get up and running and learn the system and learn how to use Skyflow and kind of make your first API call, we're lowering the barrier to entry by making it really easy, but not allowing you to do that when you're moving those things to production because you need to make sure that your security is at the highest level at that point.
That's really smart. So you make it easy to get into the product and see the value proposition from using a data privacy vault, but you hopefully remove most of the ability to create a big dangerous foot gun by leaving an API key in your repo somewhere and keeping things secure, which is, I guess, what you would probably want from your company that's keeping your data privacy in front of house.
Yeah, exactly. And I think, there's a tendency with engineers, when we're working on a project, especially when we're first start working on something, like we're going to take the sort of shortest path to getting something up and working. And unfortunately, sometimes that like prototype or MVP ends up going and moving into production before we had a chance to go back and actually, fix things. And that's, leads to a lot of these problems where, some you're logging PII and people just kind of forget about it. Or, there's even circumstances that you've seen where someone has a database with a bunch of plain text passwords in it, and it's like a major corporation. And you're just like, how did that happen? Well, it's
Yeah.
because that system was built probably 8 years ago, and the engineer that built it is no longer at the company, and everyone just kind of forgot about it because it works. And our goal really is to prevent that kind of stuff from happening, putting guardrails around this system and making sure that those best practices are enforced.
Sure. Yeah. We've on previous episodes, myself and Phil and Matt have discussed fairly regularly things like that happening in the real world with people storing their Ethereum address in a public GitHub repo, the infamous alt-right social media networks that spun up and were passing passwords through plain text and storing entire databases unprotected and things like that. It's surprisingly easy to do, especially if you've never thought about it before, and is the kind of thing that like really you can't afford to skip even once.
I recently wrote an article for our blog on how to safely store social security numbers. And the inspiration for that was if you do that search on Google, you'll see that question come up on places like Stack Overflow and Stack Exchange and stuff. And there's some good answers in there, but there's also some scary answers in there. And,
No
and
doubt.
people are going to these resources to try to answer these types of questions because maybe that feature is put on their plate at their startup or company that they're working at, and they don't really know exactly what they should be doing in terms of best practices for storing that type of information. So they go online, ask a question, and maybe they're like, oh, okay, well, I'll just start hashing it, and that will be good. But there's a lot of downsides to sort of taking the simplistic approach there.
Yeah, it is very, very easy to forget that any old person can post to Stack Overflow, and you don't have to be an expert to provide an answer that sounds right. I'll make sure. I'm going to grab a link from you from that blog post. I'll make sure I put that in the notes here. So tell me about what's next. What things are you working on right now?
So I think, we're continuing to invest in trying to make a lot of these best practices the default experience, taking the experience of like our director of security, Daniel Wong, and, our field CTO, Manish. They interact a lot with customers and educate them on when they're integrating with us, and make sure that before they go to production, they're following these best practices. And we're doing a lot to take their expertise and put it into the product. And I think there's still more that we can do with that. And because we're in such a specialized space, there's a lot that the way you sort of are defining your schema and the type of data that you're storing, it really determines the types of use cases for that data. If you're storing social security numbers, there's probably very few legitimate business cases where you ever need to see that value in plain text. So you shouldn't be able to create a policy that allows you to see it in plain text, for example. So there's a lot of things that we can bake into the product that just enforce these types of rules. Another thing that we're interested in doing is sort of TTL, or time to live, on roles and policies. That's something that you can do programmatically through our APIs today. So you could create a role, a policy, a service account key on the fly, and then you could expire it by creating some sort of background process like a cron job that deletes it after some period of time. But we want to make that something that is even easier to do, where it's point and click, or maybe a single API call to set that up. Because there's lots of use cases in the privacy and security space where that makes sense. For example, a customer support agent really only needs access to the customers that are currently in their queue. And once that person's out of the queue, they no longer need access to their data. And if you look at a lot of data breaches that happen, for example, the one that happened with Robinhood back in November, what happened was a customer support agent got socially engineered to giving up their credentials. And, those types of things happen. But once that person had, the attacker had their credentials, they had access to millions and millions of customer records. And I doubt there was millions of customers in that customer support agent's queue at that time. They just had essentially access to everything to make it easy to build that system. So if you make it easy for developers to do the right things as the default, then they'll do those things, and it'll overall create more secure systems and lead to less of these types of problems.
That's quite the snippet there too. Make it easy on the developers and it's harder for everyone to mess up. That's really fascinating, Sean. I think it's an easy use case because it's the kind of thing that pretty much anyone who's building software needs to interact with on some level, especially living in a world with GDPR. Just
Yeah.
having someone's email address is enough for them to come back and say, hey, I want you to delete everything you know about me, which wasn't always the case, right? Like what, 2016 or whenever that law came into being changed a lot of things about building software. And I've seen as Cro-Magnon approaches to dealing with that as like, well, if you're in Europe, you technically don't have access to this software or whatever. But that's just not how the internet operates. That's not how building software is in 2022.
That's not a recipe for longevity. Like, I think there's
Yes.
a huge shift that's happening in the world. I think the tech industry has been moving faster than like governmental regulations for a long time.
Yeah.
And we've kind of been telling a lie for the last 20 years to consumers that, we need to know your date of birth in order to sell you eyewear, or, we need your entire medical history to perform these types of things. And we're storing all that data, and then we're kind of using it as our property. But I think consumer awareness of these problems is changing. So there's consumer pressure on companies to do the right things. And data privacy isn't purely about compliance. It's really about doing the right things for your customers. If you look at the things that Apple has done, it's a big part of their marketing message and who they are as a company. And I think all companies could probably stand to be more like Apple when it comes to those types of things. The other thing is that there is this governmental pressure that's happening as well. There's over 100 privacy laws now in the world. So almost, most modern countries have a privacy law. GDPR is the big one that a lot of people are aware of, and that's become a framework for a lot of countries. And that's putting a lot of pressure on companies as well, beyond the consumer pressure to do the right thing. So there's this shift that's happening in the world where the sort of wild west of data privacy those days are done, and you need to start doing the right things. And I think if you do the right things from the beginning, so this, in security, there's this concept of shifting security left in the design cycle. And I think the approach that we're taking, where it's an architectural choice, it moves data privacy even more left than the left. It's an architectural decision at the beginning. It's like rather that, or when you at the same time that you're saying deciding on what database are we going to use, what kind of data are we going to store, do we need Elasticsearch, what kind of caching system we're using, all these types of architectural decisions are being made. Data Privacy Vault is part of that conversation at the beginning, and as long as you're doing those things from the beginning, it gets a lot easier when you're 10 years down the road and you have hundreds of different sources that you're collecting data from.
Yeah, earlier is certainly better. It's a bit like saying how far back you'd have to go, but there was definitely a point in time when people were like, "I'll come up with my own password hash, and I'll
Yes.
have my own algorithm for that," right? The
Or my own,
foundational
I'm going to
shift.
create my own encryption to.
Yeah, exactly, exactly. Honestly, in the last 10 years, I think SSL even over the internet was something that wasn't super common in 2010, right? Like it's only sort of just becoming ubiquitous in the past few years now. So
Yeah, and like I think some of the original pushback on SSL was that you have additional handshakes that are happening in there, so people are concerned about performance. And there's often that concern, I think, with layers of security that, oh well, it's going to hurt performance. But I think that one, making sure things are secure and private is always the right thing to do. And then there's a lot of innovation and smart people in the tech industry. And if something has to be a certain way, they'll figure out how to make it performant as well. Which I think that we've done with the our version of the Data Privacy Vault.
yeah, I think naively a lot of consumers assume that their data is safe anyway. So it's best to treat it that way when you're building out any system of any size. Sean, thanks so much for chatting today. Actually, the one thing I did want to ask you before we go is it sounds like Skyflow is growing as well. Are you guys hiring at the moment?
Yes, thanks for bringing it up. Yeah, we are hiring across all functions. So engineering, product, design, recruiting. My team also, I'm hiring for developer advocates. So if you're listening to this, you work in the world of developer relations and you're interested, check us out at skyflow.com and feel free to reach out to me as well. I'm very active on Twitter. You can find me on LinkedIn and I'd be happy to have a conversation with you.
Yeah, great. I'll put every bit of contact information that you allow me to put in plain text in our show notes. So
Yes, make sure that you get my consent.
yeah, right on. Will do. Sean, thanks so much for chatting today. It was a pleasure.
Yeah, thanks for having me. It's great to see you again, Mike.
Thanks, man. Take care.